Hi guys, this is Miss Raina here to talk to you about projectiles. I just want to give you a heads up. You're going to have to go a little bit quick today, so be ready to stop, pause the video whenever you need to fill in blanks. Alright, so let's look at what a projectile actually means. Anything that's fired, thrown, shot, hurled anywhere near the Earth's surface. So, let's see. Officially, it's an object that moves through space acted upon only by the Earth's gravity. We're moving on to Roman numeral 2 on your guided notes now. Horizontal projectiles do not have an initial y component. So think about a graph and with your hands make the y component. So your hands, your arms should be going up and down like this. Now make the x component and they should be lining up this way. If you throw an object horizontally, well, it doesn't have an initial y component. So let's have a look at what happens when you throw a ball horizontally. And remember, you guys pause and write in wherever you need to. So the horizontal component, there's your first blank, of velocity doesn't change as the falling object travels out. The vertical component of velocity determines how far away the ball travels. The vertical component changes exactly as it would if the ball were dropped vertically. The curved path is a combination of horizontal or x motion and vertical or y motion due to acceleration from gravity. Okay, so let's look at something that's launched, the path of something that's launched horizontally. If all we do is drop something, then every second that it falls a little bit further because it's accelerating on the way down. If we launch something sideways, it's still true. Every second that it falls, it goes a little bit further down because if gravity is accelerating the motion on the way down. There is nothing changing the horizontal motion. So whatever velocity it had to begin with in the x direction, it will keep. Let's have a look at what that means. We're talking about the horizontal speed is exactly the same. It's going to be constant. Pretend here in high school physics, there is no air drag. In other words, if we drop an object vertically or we launch an object horizontally, they're going to land at exactly the same time. They have the same acceleration. Guess what it is? Negative 9.8 meters per second squared, and it's due to gravity. In both cases, initial velocity in the y direction is 0 every time. Alright, properties of all projectiles. The horizontal velocity is constant. In other words, velocity in the x direction does not change. Vertical velocity is accelerated. In other words, velocity in the y direction changes. Take a minute and write down some types of projectiles that you use in your everyday life. I don't know if you're into sports or if you're into maybe shooting, other things like that. So here's another example of the path of a projectile, and if you look at the motion in y, you can see it slowing down on the way up all the way to 0, speeding up on the way down. There's the motion in y, but check out the motion in x. There's no gravity going sideways to accelerate it. Remember, acceleration is change in velocity. There is none in the x direction, so all of those little x arrows are identical. Alright, here's a couple of key points to remember for two-dimensional motion. Used all of these equations before. Two-dimensional motion is motion both in the x and the y direction. So assume the only acceleration experienced is due to gravity at the Earth's surface. Projectile motion combines unaccelerated x direction motion and freefall. No acceleration in the x direction means constant velocity in the x direction. Here are the definitions for range and for maximum height. So range is how far did something travel sideways like this. Maximum height is how far did something reach all the way up top like that. Velocity in the y direction is completely independent of velocity in the x direction. So vertical and horizontal motion are independent. Velocity in the y direction is 0 at the top of the trajectory. Alright, tricks to solve 2D motion problems. You break them all into the x and the y component. Work the problem as separate one-dimensional problems. Each dimension is going to have its own set of equations, and then you recombine the results at the end. So, a couple of reminders. Look at the horizontal component as it's making its way down. The horizontal component doesn't change all the way down. By horizontal, we mean motion sideways. Look at the vertical component. That velocity is changing on the way down because it's accelerating due to gravity. So the speed is getting faster and faster all the way down. Go ahead and take a moment to answer those questions C and D on Roman numeral 8, and then let's try some equations. So, hey, have a look. If you get to the back of your paper or Roman numeral 9, the equations are exactly the same. You have different subscripts. So for the motion in y, there's your equations for motion in y. The x ones are even better. So what do we use for the x equations? Same thing as before, except guess what? No gravity, no acceleration acts sideways. So we get to get rid of that. We end up with easy peasy, lemon squeezy, distance is velocity times time. Why do we use the total time? Otherwise it doesn't make sense. It's not like doing vertical motion where the time traveling on the way up might give us a different result or might be useful in a different way from the time traveling on the way down. So we're going to skip this box of sleeping kittens because it's morbid and scary, and also because I didn't actually ask a question in that example. And let's go straight to the tiger leaping horizontally. So here's a sample. Let's say the tiger leaps from a 15-meter high rock. So I'm going to take a pen from here and then put that away. All right, and we're supposed to figure out, so this is 15 meters high. 15 meters high is going, oops, that's supposed to be like that, is going up and down this way. So this is going to be distance in y. And a speed of 4 meters per second. It was launched horizontally, so that tells me my initial velocity is in x. And we're supposed to figure out how far from the base of the rock. And some people will see this question and they'll say, well, you already gave me my distance. But if I'm asking you how far from the base of the rock, I'm asking you how far like that way. Horizontally, not vertically. That means you're going to solve for distance in x. So to take a stab at this, we need to split up x's and y's. X information from our y information. So we're going to kind of split up information like this. So we have got distance in y. We know that. That's 15 meters. We also know initial velocity in x. That's 4 meters per second. Sorry, it's kind of hard to write on here. Oh, it looks like that's all we know, but it's not true. We know acceleration in y. And we also know initial velocity in y. We're supposed to figure out distance in x. So let's see, how can we do this? In order to get distance in x, we're going to need time. Let's get the time using this info. That tells me I need an equation that has time, distance, acceleration, and initial velocity, and we're going to use the same variety we've always done. There we go. So 1/2 at squared plus v initial times time. Acceleration in the y direction is from gravity. We have no initial velocity in the y direction, so that goes to 0. Let's isolate this time. So I'll multiply both sides by 2, get rid of that term. Divide both sides by g, get rid of that term. And now I need to take the square root to get rid of the exponent. So rewriting, I'm going to do time is square root of 2d over g. Once I substitute my numbers in there, that's going to be 2 times my distance in the y direction, 15 meters. And I got to divide that by my gravity, 9.8 meters per second squared. And you say, hey, wait a minute, that's supposed to be negative. But the truth is, that's supposed to be negative too. It fell down. All right, we end up with a time of, let's see, about 1.75 seconds. So pretty good so far. Now we got to use this time in this info to figure out, what our distance is in the x direction. So in order to get distance in the x, same equation, except now acceleration is 0. It means distance in x is just initial velocity in x times time. All right, so let's do that. Initial velocity in x times time, we have 4 meters per second times 1.75 seconds. Easy. Okay, so we got 4 times 1.75, we end up with a distance of 7 meters, and you got your answer. So I know it looks crazy messy because I'm not used to the whiteboard changing into a smartboard, but go ahead and write down any questions you have, and we'll do some more examples in class tomorrow. Thank you guys for sticking through this longer video. See you tomorrow in class.